Hello, my name is Dr. Matthew Lazzara, and today we're going to talk a little bit about the Polar Climate and Weather Station project. So this is an opportunity we've had to kind of develop a brand new electronics core for the automatic weather stations that run in the Antarctic. And I wanted to emphasize, as you can see here by the various logos, this is a project that really includes a lot of people. It's not just a solo project that I'm doing alone. There's lots of folks involved at Madison Area Technical College, as well as the University of Wisconsin-Madison. So we're really excited to all of these folks you see here who have made this possible. So we're going to go through a little bit background for you, some of the goals and objectives, and then talk about what we're doing here with the actual, early development. We're kind of sticking to a basic instrumentation suite. Some of our first work, some of the installations we've been doing in the facilities we've got, and we'll also chat a little bit about how it's gone so far and some of our plans for the future. So the weather station network in the Antarctic began in 1980. Yes, it's our 40th year that we've had automatic weather stations as a formal network in the Antarctic. And a lot's evolved since this map in 1980, which involved those of us at the University of Wisconsin in collaboration with those from Australia and France and the United Kingdom, to today where it is a tremendous network. We're getting into the 160 to 170 automatic weather stations across the continent, and we're running about 60 of those at the university, and now we're adding a few here at Madison Area Technical College to the collection. And so we're kind of getting up there with lots of contributions from lots of different nations. So the goal of this project was really to do a few things. We wanted to develop a new electronics core. I have to admit the motivation is mostly so that we understand everything going on when we make measurements all the way through their processing until we get an actual science value. And being something that can be affordable and be used for not only weather, which is what the original weather station network was built for, was weather, not climate. And it would be nice to be able to know that we have some client reliable observations, especially in the area of temperature, and the opportunity to expand the observational suite. And there's a lot of capabilities to do this with commercial off the shelf, but those systems are built for worldwide use. This is intended for polar use. We wanted to have students involved at every aspect of the project. And so they are included all along. That they were involved in the proposal writing, the actual execution of the project, being in the field, doing the electronics, the meteorology research behind it. They've been involved in every aspect. And now when we start to develop this kind of thing, we have electronics and weather data that's going to end up in the classroom. At Madison Area Technical College, we really have a hands-on electronics study area, as well as folks who are doing exploratory, kind of the freshman or sophomore level weather climate classes. And it's a great opportunity to be able to have the data get used in a classroom setting. And really, if this project does have the success it's supposed to attain, we aim to be able to make the weather station data that comes from the PCWS project that community resource for everybody to use. Now, we're not going to be really changing sensors at all in this project. We're going to use well-known, well-established sensors. We've been playing around with this for a long time, and this is the collection. We're going to stick with platinum resistance thermometers as a basics, but we're adding thermistors, especially at the actual main level where observation is done at the top of the tower. A lot of weather stations only have a single temperature sensor, and we wanted to follow the United States Climate Reference Network, where they really are measuring it at 3 sensors at level, so we can make sure what we're getting for measurement we're comfortable with. And actually, we hope to get it at a couple of different levels on the tower. We'll use very classic standards for relative humidity, pressure, wind. These are the same systems you see listed here, the exact same ones that are used now in the Antarctic. We have the opportunity here to add additional components that are becoming highly demanded by the science community. For example, being able to measure the accumulation of snow next to the stations. It's great for a maintenance standpoint from our end, so we know if the stations are getting buried, and it may have some value for the glaciological community. Radiation, heavily in demand, getting to know incoming and outgoing radiation, both long wave and short wave components. We're going to try. We'll have the sensors. Keeping them clean and pristine is always a challenge with a sensor setup and a weather station setup that's out there a long time. And we'll get the chance to play with some other things like these acoustic geophotometers to catch blowing snow. The communication method is going to be iridium. It's a variety of reasons that have got us there, mostly that the U.S. program is heavily geared toward that these days. And we're going to try to not only get the data sent out in real time, because it's valuable for weather forecasting and numeric weather prediction, but also have it stored on board in a couple of different methods. This is our early work. You can really see the beginning of developing these boards. And yes, we do have a freezer that we can test them in down to -85 Celsius to make sure the components we're picking, even though they may not be electronically officially spec'd for that, work in the environment we're putting together. We've got a couple of test facilities, one at Madison College outdoors, which is great. We've never had this opportunity at the university to be outdoors in a place where you'd have a snowfall and be able to, have that be your backdrop, even though Wisconsin winters can be cold. They're not Antarctic, but at least there's something to be testing out there. And we have a facility out at Williams Field. This is our test facility, and we've been using that for many years for the weather station program, and now we're able to do it for the PCWS program as well. So this spot here is our test site where we're actually able to start trying things out, and it's really great to have that. So our first installation in 2018 were pretty good, although we discovered some -40 flaws. It's a really common temperature at about -40, which is both the same in Fahrenheit and Celsius, where a lot of electronics quit working. And we discovered a flaw, but we fixed that. And that was a great learning exercise to build a board, put it out there, and discover that issue. We really didn't get the chance to relay any data out in this first test because it wasn't ready in time. This station, by the way, we've named Sarah AWS site, and so I have a little bit here about it in case people are curious. There's the background information. We were excited in 2019-20 that we got some data finally relayed out. Here you can see temperature information coming from the station. We were really excited about that. We changed the design of the board here in the next version. You can see the different connectors and so forth used in this system. So we've had some good successes. It's got some challenges still that we're working on in our last year of the project. I think one of the big successes is getting students involved everywhere. We really did that. 5 electronic students and 3 in meteorology. We got a viable system running. We're still doing it at a cost rate that is more affordable than some systems you can get off the shelf for the electronics core. We still have some design issues that we're still working on. The current system out there didn't work after a while, mostly because we believe the communications method, which is a very intensive method. Iridium takes a lot of power, drain the batteries quicker than we had the opportunity to handle some switching issues. So there's always minor things to be done, right? But we're excited that we've given students, a STEM experience, right? Not all the students involved in this project are going to run into a career in Antarctic meteorology, and that's okay. One is considering that, which is great. We've got others who are pursuing areas in either atmospheric science or in science policy. And that's lovely. Or, the electronics folks aren't going to be electronic experts for the polar regions, but they will be out there taking great interest in their discipline. And we're excited about that possibility to get students that experience and move them on. We're happy that the project's kind of worked out in a timeline that now, as soon as we do get the chance in a future field season, this current one with COVID-19, we won't be likely doing this, but we're going to be doing some side-by-side testing with existing weather station sites. And some that are actually going to have a 3rd weather station installed at these locations. So we'll continue with the Sarah site at Willie Field, which is really great. We're also hoping to do one at a very windy location that's nearby McMurdo Station at White Island. So we're really excited about testing a high wind site to make sure we can really capture great winds. Another site that has a lot of relative humidity variability is at Maryland site. It's a site that on the Ross Ice Shelf where there will be 3 weather stations there, the new PCWS and a Wisconsin standard station, and then some folks from the Mac Weather office are going to have some of their equipment as well. And this will also be the case at Elaine and Schwartfeger sites. So this gives us more diversity across the Ross Ice Shelf, and these are really great opportunities to get some confidence in the data we're getting from these stations. So we're getting closer to having another version of the board, which is great, and we're excited about that. Work is taking place as we speak. And we'll be continuing to integrate some of these fancier sensors, which we haven't had the chance to field yet. That's something that's coming up. And then we get to do some testing, both, continuing to do testing in our freezer long-term, right? Get stuff in there, really cold, long time, see how it operates, as well as getting stuff out in the field, which I had hoped to be this current year, but it looks like it'll be a future year, as well as testing outdoors here in Wisconsin, which we're excited about. And, of course, documenting it. Right? So we can keep making use of this, and actually we learned a lot about how the extremes of our network worked, and so we're hoping to publish a little bit more about that in the near future. And then, we'll be hoping to create a few systems down the road that'll be around for use. So I can't thank you enough for a few moments to talk about all this. We could not have done this work without support from the National Science Foundation and the team of people at both Madison College and UW-Madison who have done all of this very exciting work. So we thank you very much for that. And with that, I'll stop. And I always encourage people to contact me with questions. There's my email address here where you can contact us. And I leave you with a quote from Dr. Stearns, my predecessor, who first started the Automatic Weather Station Network in the Antarctic. And so thank you for your attention.